freecoachingtoday.com, world's largest e-learning site.
Okay, we will continue to learn more about Coulomb's law, and we know that the magnitude of the force between two charges is given by K times Q1 Q2 divided by R square. Now force is a vector quantity, is a vector, and when it's a vector, it means it has a magnitude and a direction. But this formula does not give the direction of the force. Now, let's say we have a coordinate axis. This is the x-axis and this is y-axis. Let's assume that we have a positive charge right at the origin of magnitude q1. And then we have another charge at distance r2, at distance r on the axis x, its magnitude q2. Okay. Now, we know that these two charges repel each other, which means that the force, the direction of the force on charge q2 is going to be in this direction, which is shown by this arrow pointing toward the positive x-axis. So we formally define, in case of this q2 is a negative charge, this force on the q2 will be in this direction, which is the force of attraction. So this is formally defined as force vector F vector. If we are using a formal notation of vector algebra, and we represent it as k times of q1 q2 divided by r square multiplied by r vector divided by the magnitude of r vector, which essentially gives a unit vector pointing in the direction of the line joining q1 and q2. Now we will not use a formal vector algebra, but we will show what does it means when you have more than one charges in any two-dimensional geometry. Let's say we have three charges, q1, q2 and q3 lying in the space, and we have used arbitrarily chosen q1 to be at the axis, at the origin of this two-dimensional axis. Now let's say we want to find out the force on this charge q2 due to q1 and q2. What we do? How to solve this problem? We join the line q1 and q2 and we find out the force on q2 due to this charge q1. And then we can find out the force on charge q2. Let's say we call this force F1, the force on q2 due to the charge q1. And then we can join the line q3 to q2 and we can find out the force on q2 due to q3, and the direction of this force is going to be in this direction, assuming all the charges are positive charges. Now, the total of this force F1 and F2 is going to be somewhere, it's a vector sum of force F1 and F2, and for which we can use a parallelogram rule and to find out the resultant force F vector, which will be given by F1 vector plus F2 vector. So that's how we solve the problem. We will take up an example in the next video of how to solve the problem of multiple charges interacting the forces among themselves.